So you have little bit knowledge about limits?
No.
Limits is a base. Okay, no. All right. Give me a minute. Because if you know limits, then only you will understand this thing, differential calculus. See this, when it
Should I
comes
turn
to
on my camera?
calculus is two types, differential and integral. So if you know differential, then you can understand integral easily.
Okay.
Now, when it comes to differential calculus, you should have knowledge about limits and continuity. That is basically the starting of calculus. So let me start with limits first. If suppose I give you a function this, can you tell me the value of the function at x equal to 2?
7.
Yeah. So f of 2 will be, you are simply going to replace x by 2. So this is 7. All right. Suppose this is a function. Can you tell me the value of this function at x equal to 1?
5.
Will it be 5 by 0?
Oh. So that'll be
It
0.
becomes, yeah, so it becomes 5 by 0 form. And whenever you divide by 0, it is not defined, isn't it?
Okay.
Right. So actually, this function is not defined at x equal to 1. And x equal to 1 is the only value where this function is not defined. Agree?
Okay.
Because otherwise, you can take value of x, any other real number. You are not going to get 0 in the denominator other than 1 if you take.
Okay.
Right. So x equal to 0 is the only value where this function is not defined. So what we do for such functions, we find left hand limit and right hand limit. I know that this function is not defined at x equal to 1, but I want to have an idea of how this function will behave when x is close to 1. I know at x equal to 1 it is not defined, but I want to know how this function is going to behave when x is close to 1. So, see this. X is 1 here. Let me take it. Suppose this is 1. This is 0 and this is 2. Inputs are always written along x-axis and outputs are always given along y-axis. I want to know the behavior of this function when x is close to 1. Means when we are approaching x from its left hand side. Also, I want to know the nature of this function when we are approaching x from its right hand side. All right. So when we are approaching x equal to 1 from left hand side, so I think I can have the value. Yes. I can have the value. I can have, and so on from left hand side of x. So if x equal to 0.9, let me check what will be the value of function at this. Yeah. Yes. And this you know that you are going to calculate it. Let me tell you. This value comes out to be 4.6 divided by minus 0.1. All right.
Okay.
So this comes out to be 4.6 divided, just a minute, This comes out to be minus 46. Next, let me check the value of this function at this.
Can I quickly get my charger real quick?
Yeah,
It'll take a minute.
please. Yeah.
Okay.
All right. So same way, if I put the value here, then you get 0.99 plus 1. And the value comes out to be, let me check it, 4.96. Sorry, this was minus. Divided by, so your answer comes out to be 4.96 divided by 0.01. Just a minute. Did I do something
If you're
wrong?
estimating it, how do you estimate when it's like 4.96? Like round it like to the nearest 10.
Yeah. Wait, that's what now? I did something wrong with the calculations. It is 4.96. You are saying that it will be near 10. Why?
No, I'm saying if it says, like if a question says like round it to the nearest 10, what would it be?
Okay, no. See, Abhi, if you are saying, don't say first of all 10, it will be 1, approx 1. 0.99 approx is 1, not 10. It will be 1.0, right? See, let me see, because now calculations are going to be little difficult. So let me help you with the graph. Say this. Or first, let me tell you the literal meaning of limits. For example, you are watching a football match. Okay? You're watching a
Okay.
football match and you see that one player is here. This is the net, and one player is here. This player kicks the football and it is somewhere here. And then suddenly, due to glitch in the network, your screen goes blank. Okay? Then just
Okay.
after a second, you see that the ball is here. Right? Now, I'm interested in the position of a ball when